Hey guys, Mr. Leo here. I just want to go ahead and walk you through our 5.4 practice with our alligator problem. This is doing a power regression. So first things first, let's enter these data points into our calculator. I'm going to put length into list 1 as my x values. Oops, list 1. And weight into list 2 as my y values. All right, so these are going to be x. I want my pencil. X, y, x, y. Okie dokie. So here we go. It says create a scatter plot of the data of alligator lengths and widths. So make sure you label your graph with the context as well as the list that you use. And we're plotting here list 2 versus list 3. So go ahead and do that now. All right, so I'm not saying that mine is perfect, but this is what it should look like about. Describe the scatter plot. Okay, so this scatter plot, it appears to be increasing. But not at a linear rate. The data is curved. Okay, and let's check this out. What is our R value? So you should run a linear regression, just in case you don't remember. You're gonna hit stat, calc. Linear regression is option 8, and you're looking at list 1 versus list 2. So there's your calculator pathway. And for R, you should have gotten 0.925, and for R squared, we should have gotten 0.856. You can also get your least squares regression line from that, and we should be getting y hat equals negative 412.58 plus 6.20x. All right, so now I want to look at the residual plot, and I want to find out what it indicates. I'm going to just start off by making a little list of what I've got going on here. In list 1, I've got my x values. List 2, I've got my y values. List 3, these are going to be my y hat values. And I'm going to enter negative 412.58 plus 6.20 times list 1. So I'm basically plugging in every single x value that I have here into this equation and getting those outputs on list 3. And remember, for your residuals, you want to plot, or in order for list 4 to happen, we want y minus y hat. Y is list 2 and y hat is in list 3. So that's what we're going to do for list 4. Let's go ahead and label our axes. Okay, and we're going to label our y-axis. This is going to be residuals. And this is in our list 4. Oops. Versus x values, which are still in list 1. So I'm going to pause the video. You guys go ahead and get that residual plot graphed. Okay, again, it's not perfect, but this is what it should look like somewhat. And now we're asking, what does this residual plot indicate? Okay, so since the residual plot shows clear curvature, this would indicate that there may be a better model. There may be, oops. a better model to show the relationship between alligator length and width. Okay. All right, so down here, it's asking us kind of a similar question. It's saying, how appropriate do you feel the linear model is for this data? All right, so we have 3 things to look at. First thing, the scatter plot appears curved, not linear. Okay, my R value is strong, but it's kind of like that case that we saw in class. The line doesn't fit the trend of the data. Just the data points are close to the line of best fit, but that doesn't mean the line of best fit follows the trend. My R squared value is high. It's strong. But lastly, that residual plot has a clear pattern. So I've got bad indicator, a bad indicator, an okay indicator, and a bad indicator. So how appropriate do you feel a linear model is for this data? Linear model doesn't seem to be the most appropriate. Okay, what transformation do you think will be appropriate for this data? Explain why. This is up to you guys to decide what kind of transformation you would like to use. I'm going to use a power model. I'm going to take the natural log of both, and you guys can follow along with that or do whatever you want, but I'm going to use the natural log of both. I'm going to use a power model. Just to give you guys an example. Okay, so the natural log of both x and y. So use an appropriate transformation for the data. Okay, create a scatter plot below. Perfect. So I'm going to do this now. So in my list, I'm going to get rid of my old list 3 and list 4. And I'm going to replace them with the natural log. And I'm going to plot these on here. So I've got the length, which is going to be list 3. And in list 4, I'm looking at the natural log of my width. And I'm going to give you guys a second to graph that up. All right, again, not perfect, but it should look something like this. Describe the scatter plot. It seems to be positive, increasing, and I do see a linear pattern. All right, so we're going to calculate our R and R squared value using linear regression. And we should get an R value of 0.9704 and an R squared value of 0.9418. Our least squares regression line should look like this. So you need to be careful because when you run that linear regression, we get y hat equals negative 10.29 plus 3.32x. But one thing you need to remember is that we took the natural log of these things. So I actually have natural log of y and natural log of x in there. So in order to undo this, I need to raise both sides to the base e. So my y hat equation would actually be e to the negative 10.29 plus 3.32 ln of x. Okie dokie. So there we go. Find and interpret. So let's interpret the r value. Maybe down here if I have room. I'm running out. So there is a strong positive linear relationship between the natural log of length and the natural log of width of alligators. All right, let's interpret this r squared value. 94.18% of the variation in y, which is natural log of width, can be explained by the linear relationship with the natural log of length. All right, so we interpreted those r squared values. Now it says graph the residual plot for this data. What does it indicate? All right, so up here, we're gonna add, I'm gonna add to that table a list 5. And in list 5, I'm gonna input this equation, e to the negative 10.29 plus 3.32 ln of x. And x is, just so you're clear, in list 1. So you want to input list 1 right there. In list 6, we want y minus y hat values. List 5 holds our y hat values. And list 2 holds our y values. So we're going to say list 2 minus list 5. And over here, I'm looking at x, my original x values, which is length, list 1, versus my residuals, which are in list 6. I'm going to give you guys a second to do that. Okay, guys, so this is kind of what your residual plot should look like if you did the transformation I did. What does it indicate? This is kind of a complicated one because we could maybe interpret this as some curvature, but really we just seem to have a clump of random points with 2 unusual points. So that's something that we may want to point out. There may be a better fit for this data based off of what we are looking at here, okay? So the residual plot shows that there may be some curvature, or we just have 2 out of place or unusual values. This would suggest that there may be a better fit for the data. Okay, so we might have a better fit. This is kind of a tricky residual plot to look at because we could interpret it as random and then 2 points on the outside, or we could kind of interpret it as a curve. But I definitely would say that there's a little bit of pattern happening here. And with this r and r squared value, yeah, there might be a better one. Okay, we can probably do better. So, however, now we have two models to choose from. We got to choose between the top linear model or this bottom transformation that you used. So what do we think is better? Okay, given the two, it would seem to me, let's look. Okay, so the second scatter plot, I'm actually not going to use the word second. I'm going to use TF for transform scatter plot appears to be more linear. Than the original. Okay, so we talked about scatter plot. Okay, both r and r squared values are larger for the transformed data. Okay, and although both residual plots are not ideal, ideally random, the original resid plot has a more clear pattern of curvature than the transformed data. So if I had to pick, what would I go with? I would go with the power model is a better fit. All right. Last question. Notice in the data that there's a gap between 94 and 128. Use appropriate model to estimate the weights to the nearest pound for alligators. So we're definitely going to use this equation up here to make those estimations. You're going to input x as 100, 110, and 120, and you should get out 144.34, 197.97, and 264.15 respectively. Okay guys, so hopefully this was helpful for you to look at the key. Even if you didn't use the exact transformation I did, maybe the steps will help. You kind of had, it open to you to decide. Remember to always keep your list straight, label and be precise. Tell me your 4 justifications when choosing an appropriate model. And of course, if you need any help, come see me during office hours. Okay, bye.